Cool. I guess we have 13 viewers around here, so yeah, we can start. So welcome to first PyTorch Lightning. One second. First PyTorch Lightning Twitch live stream. So since it's the first one, we will go through how you can make your first contribution to Lightning package. So people who are not like familiar with what is Lightning, what does PyTorch Lightning does. So it's sort of like a wrapper around PyTorch. So you can build your training pipelines, inference pipelines using PyTorch Lightning. Plus, it provides you with things like helping with your code organization, helps you plug in extensions, callbacks, and all kinds of stuff that can help you with training, distributed training with no code change. So that's sort of like an ideology that we follow here. If you want to like train on distributed clusters or distributed devices, you don't have to make any changes. Just leave some make change some flags, and that's it. You're good to go if you have all the access. So yeah, that was some intro about okay, yeah. We also have George from StatQuest here. He recently joined Grid. So yeah, awesome. So PyTorch Lighting is backed by Grid.ai, I'm Rohit. Sorry, I forgot to introduce. My name is Rohit. I work as a research engineer at Grid.ai, mostly working on PyTorch Lighting. And let's get started. So awesome. So we already did the introduction for Lightning. Now let's do some introduction regarding Git. What is Git? Just some basic intro in case someone is not familiar with it. So consider a use case. Let's say there's a project that is present online and you need to use it for your own use case, or you are a developer on that project and you saw a bug while using it, or you need to introduce some changes. Maybe it can be refactoring, it can be a feature or anything. Now it's not easy to just make some changes and expect it to be deployed on the main branch, or you can say in production for that software. So this is the place where Git comes in. Git allows you techniques or like plug API that can help you with contributing to open source packages without like directly merging on it. You can propose your changes, you can discuss your changes, and do everything. Plus, it also tracks who makes the changes and when those changes are made, so that it can help make software development easier for everyone. Now, Git was built by Linus Torvalds the guy behind Linux. This was Git. Now we have GitHub. So GitHub is sort of like you can say a UI for Git. Now it's not like a lot of developers are working on a single package or single software, and maybe they may be present at different places in the world. Now GitHub provides them the UI to interact, like, and plus a lot of things are there. It has actions and everything, but on the basic level, it's sort of like a Git with an UI, so that you can interact, do some code reviews, discuss, and all that good stuff. So for this stream, we will be going to the complete process, how you can find issues, how you can make of your first contribution, or even if you are an existing contributor, it's sort of like a refresher. You can take it into consideration. So specifically for this particular stream, I have like this issue. So I'll explain this issue a little bit, then we'll move forward with all the steps that are required. Let's start with the issue. So if you are familiar with distributed training a little bit, when you are doing distributed training with DDP, it's basically distributed data parallel. PyTorch uses distributed data sampler to configure data to distribute data across the devices. But there is sort of like you cannot say it is a bug, but it's sort of like a feature that is reliably not efficient in distributed data parallel, and that is when it distributes the samples. Let's say let's take an example. One sec. let's say you have a total dataset size of 100 and your total batch size is 32 and total number of devices that you're training on, yeah, or distributed training is being done on, it's four. It's let's say four. Now what happens is let's consider two for simplicity case. Now total effective batch size that in a single process will be 64. It's basically batch size into total number of devices. But what happens is when you are using distributed data parallel, it needs to ensure that all the devices gets the same number of samples. If you are like, if you can also check the code here. What happens is to synchronize all the metrics across all the processes. It needs to ensure that once it does all reduce at the end to compute final metrics, it needs to have all the devices should have same batches. So what happens is, let's say you have 100 sample size, but your total effective batch size is not a it's not syncing up with the total batch size. So it adds the extra samples to make sure that all the devices gets the same number of samples. So let's say you had 100 samples initially and you are doing benchmarking for a research report. But if you are doing that benchmarking using data parallel, then and using and calculating metrics across all the data set, then due to the extra samples, the final benchmarking might not lead to correct result. Like not if not it won't represent the actual metric. Right. So we need to ensure that when user is using Lightning and they are using distributed data parallel and doing some kind of evaluation, it can be just a validation or it can be just testing. We need to make sure that they know that behind the scenes distributed sampler is being used, and we warn them that you should for benchmarking and that all that kind of stuff. You should consider using single device for benchmarking stuff. So this is like all what we need to implement. It's just that we need to add a warning for the cases in which evaluation is happening using a distributed data sample. So that is sort of like an overview of the complete thing that we need to do. So whenever we in Lightning, there are four things you need to take care of, majorly in all the PRs. You need to update the code base. You need to add a test, and you need to update the docs, and you need and update the change log. These are like the four things you need to follow. But out of these three- out of these four things, this is the most difficult part. Then once this is done, I think testing depends upon how complex your solution is. But yeah, we'll go through all four steps in this live stream. So first thing we need to do is, if you are like not familiar with Git, if you haven't done any contribution or anything, first thing you need to do is go to the project. Okay, yeah, we have the project here. So this is PyTorch Lightning on GitHub, and we have master branch. Master branch is basically, you can say, that is the state of the art code. Like the top notch changes, all the changes are present in the master code, and you cannot make changes directly to master. You need to suggest changes. Now to suggest changes, you use PRs. You create pull requests and let reviewers review your PR, discuss, and once it is finalized, it gets merged into the master. So, and make to start with it, first you need to do is you need to fork it. Uh, if you need to log in, of course, with your GitHub account, and once you fork it, you'll get an exact copy for at this commit. Like if I'll check, I've already forked it. So if I check my account, here is it. So right now, this project is under my username, but it has been forked from PyTorch Lightning. So whenever, if you are not part of the organization, this is how you'll do the stuff. So that's why this whole thing you need to do. So once you have this thing, you need to clone it to your local system to start making changes to the code base. So to do that, you go to code and copy this. You can copy the HTTPS one or SSH one. It doesn't matter. So once you are here, you can Go to your terminal, go to some, let's go to the root. For this one, we have this particular folder, and you can do git clone and copy that link that you copied from your GitHub repository, not the PyTorch writing one. So I've already done this part, so I'll skip it. Now you will see that I have PyTorch writing here. I can go to that package repository and see all the files that are present here are already present at this place as well. Plus, if you need to check whether how is it, like, is it deflected from the repository or not, you can do a git log and see the latest commit. So here you can see that latest commit is something else. But if we go to the repository, the actual repository, you'll see that this is something different. That means the uh, repository is not perfectly synced yet. So to sync it, you need to add locations, sort of like remote locations of the package that you have already forked. So to do that, there's git command, git remote, add uh, something space the actual repositories path. So here you need to define the tag for it. Like for each kind of remote repository, you need to define a tag. So for the one you have already forked and that is present on your personal repository, it is usually used as origin, and the one you are trying to make changes, it's usually called as upstream. Since this one is for PyTorch Lightning, I call it upstream. This is a tag. You can refer it as a tag so that you can make changes to a particular tag. Now, once it has been added, you can check it with remote with this command. So this tells that origin is my personal username's Git repository, but the upstream that I need to make suggest the changes or I need to push is basically the one from PyTorch Lighting itself, PyTorch Lighting organization. Plus, it shows that you have the fetch access and push access. So push access means that you can make a push, you can suggest a pull request. Fetch means all the recent changes that are not present at your local repository. You can use the fetch command to fetch all those changes and sync with your current repository. So recently we saw that uh, the latest commit is something else, update, test pruning or something. But if we see the latest commit on the repository, it is something else. So to do that, you just go to git fetch upstream. So this fetches all the upstream branches from the upstream, all the branches from the upstream. And once you are done with that, you can rebase it. So rebase is sort of like a sync. If your local branch is not updated, you can do a simple rebase, and it will sync uh, your local branch with the master. So we are defining for which branch we need to rebase. This is upstream, and we need to rebase master. So once we are done that, it will successfully rebase. And if we check out the log again, we can see that now our local repository is perfectly synced, and we can start with the changes that we need to make. Once we are done with that, we can start with like whenever you are making any changes or anything, don't do it with master. Try to always create a branch. So to create a branch, it's the simple command is branch dash sorry, it's git checkout. uh, let's rename it one distributed evaluation or something. It can be anything, but it should slightly reflect what you are trying to do in that particular section, in particular PR. So here we are trying to add a warning, and it's related to distribution evaluation kind of thing. It doesn't create. So we need to add a, since this particular branch doesn't exist, we need to assign a flag to it. Now we are on that particular branch, and if we see the commits, we see that it basically copied master code, exact master code, to a different section, so that we whenever we make changes, we don't change master at all. It's totally separate. And okay, there are some questions. Let's take it at the end. Awesome. So we can see that we are on master. Now, second thing you need to do is you need to create an environment. Always use environment when you are using Python. that's recommended. So for this one, I'm using Conda, and to create a like you can check out the Conda command. So for this one, we have this thing. I've already created the branch, so I'll skip this part. And to check out the to go to that particular, sorry, not the branch environment. To go to that environment, you can just Conda activate that particular switch PLSC branch name. And this is sort of like a completely different environment, Python environment, and you can install repositories, do any kind of stuff. It won't affect any of the other packages that are being installed on your personal system. Now, once we are basically done with sort of like a initial part. One stage is completed. We have the branch, we have the environment. Now we can start with the implementation. But before implementing, we need to install some packages. So in Lightning, when you are contributing, there are like a lot of packages, but we have divided them separately so that you don't have to install all of them. So the basic one is just if we do simple ls, it's requirements.txt. So this is like the base level. If you need to use PyTorch Writing, these packages should be installed. So we can just install it using simple Python command requirements.txt. And okay, one sec. Let's- Yeah, packages are installed. Now, since you are a developer, there are a lot more packages that you need to install. If you are not a developer, you are just using Lightning, then these are enough. So external packages are stored under a repository. This is requirements. I clean it up. So if you are changing some sort of test, you're writing tests, you need to install test.txt. If you are changing docs, you need to install docs packages. If you are doing some sort of distributed training or doing much more than that, then there are some dev packages and I mean you can go over them. So for this one, we need to, as I mentioned that one sec. We need to add a test, we need to update the docs. So we'll go and install test.txt and we'll install docs.txt. So we can just do, we can, let's see these and get, okay. One sec. Yeah, also one more thing. With Lightning, there is some Git sub module you need to do. So it's all present on the docs. I'll show you after some time. Um, okay, we are done with this part. Let's go to requirements and install them again. Let's install test.txt. Awesome. Now we are done with all the installation, all the setup. If you have this setup already, then you don't need to do it every time, of course. So this is just a one-time job, most of the time. Yeah. So now let's go over the issue once again. We need to add a warning in case a distributed sampler is being used in case of trainer test or trainer validate. So to do that, what we can do is like it's sort of like you need to have some familiarity with the code base, like when where things are happening, and even if you don't have, you can still open the issue. A lot of lightning researchers or from anyone from the team will be of course happy to help you with where you need to make changes and how things need to be done. So for this one, since I of course a lot familiar with lightning packages, so I can just go with the implementation part. So let's go to the code base and start with it. So yeah, these let's do this. Okay. So to do that, what we need to do is uh, we can go to data connector. So here we can see that data sampler is being imported. That means it's being data connector is basically something where a lot of data handling part is being done. And since distributed sampler is somewhat related to data, majorly we'll find that things needs to be changed here. A warning should be added somewhere around this code. So again, you need some familiarity with this, but if you don't, of course, we are happy to help you. So in this one, we can see whenever Lightning introduces like loads a data loader, it uses reset val API. So what we can do is we can search for reset these. One sec. Okay, yeah, here it is. So here, this particular API is being called whenever you are using it, whenever evaluation data loaders are being loaded. So we can go line by line and see where actually the sampler is being loaded in case of distributed training. So here we can see that it is requesting a data loader at this point. I mean, some things are being created from the function init, right? But we have the data loader here. We have. Okay, yeah. We have the data. We have loaded the data loaders. Now maybe something we are preparing the data loader. Maybe here, this is the point where we are adding a distributed sampler. So we can go to this particular uh, definition and see if things are being done here or not. So let's go down and see. We are resolving some samplers here. So maybe this is the point that is where the sampler is being loaded. So let's go here and see. Yeah, so yeah, we found that somewhere in this particular code, a distributed sampler is being requested and returned so that it can be updated to the sampler code. So here we can see we have a private function, protected function that calls get distributed sampler. So if we check this one, we see that in case of evaluation, if it's not a prediction, we use the distributed sampler. I mean, here you can see, and we return this thing, and if it's running under distributed sampler condition, I mean we are using distributed sampler strategy, we are returning that kind of sampler. So here we are sure that okay, this is the point where a distributed sampler is being returned in case of evaluation. So what we can make changes here. We can see that if we are running we are running an eval mode, then and using a distributed sampler, then we should raise a warning for the user. So to do that, we make some changes here. Okay. So now we got the sampler, and we need to add certain conditions. So the condition will be is is sampler distributed? Are we running eval mode? If yes, raise a warning. That's it. That's all we need to check. So to check the first condition, we can do something like if if is instance sampler is a distributed sampler, right? First condition is done. Okay. If this is happening, then we need to raise a warning here. Let's comment it out. Second condition is, are we running an eval mode? So usually there is a like a trainer instance attached to this data connector that tracks whether the current condition is being under eval mode or not. So for this we have let's assign it to a variable. So it's basically one sec, we have some questions. Okay, what tool you use for auto completion of the terminal? It's I don't remember actually. It's if you search on Google, it's Oh My. It's one of the plugin by Oh My ZSH, I think. So ZSH is it's the terminal that I'm using, and that particular auto completion is a tool out of it. So it basically searches your ZSH history and displays the recommendation based on it. Is there any documentation explaining the entire architecture of it? Not yet. Like there is at until certain level we have documentation that explains where things are happening, but these are some of the things that are too much internal. So you can like see that where let's consider this example only. We when we run trainer or test, you can walk through the code and see where things are happening, right? You can inspect inspect into that particular code and see, okay, these are the places the changes are made. So you need some familiarity with the code. It's not like so simple that I mean everything cannot be on the docs, right? So now we already satisfied one condition. We need to check the second condition whether it's running in the eval mode or not. So for this one we have it's this is the particular thing that tracks whether it's under a trainer, whether it's running evaluation or not. So it's sort of like when you are doing trainer.fit, it stores a flag called fitting. If you are doing trainer.validate or something, then it stores validating flags. So we need to raise this particular eval moding when we are doing validating or testing, because we saw for prediction it doesn't use distributed sampling. So first condition is done. Second condition is uh, trainer function in. Okay, we need to import it. Let's use VS Code auto import. Yeah, it must have already auto imported it. So these are the two conditions. Once these two conditions satisfies, we need to raise a warning. So to raise a warning, we can simply do rank 0. There are certain utility functions that you can use to do that. Rank 0 1. So add a warning here. So now we are done with most of the part. Like we are done with the code base mostly. Now we need to see what kind of warning do we want to raise. So we need to tell a good message to the users why we need it, what's happening behind the scenes, and why you should consider using a single device. Let's for specifically for this particular thing, right? So we can just say that using this sorry distributed sampler with the data loaders, it is recommended to use single device training with evaluation. Like you can improve this message, but like for the purpose of streaming and that, let's not focus on that one thing. You can do it later as well. Let's divide it into multiple lines. Do we have any questions? Okay, no. Great. Now we are done with the first part. We are done with the updates in the code base. Second thing we need to do is we need to add a test, right? So to test as well, in most of the case, like majority of the cases, you if this file is named as data connector, you will find a test named as test underscore file name. So let's search it. We found that okay, if something is happening, we can add a test that can unit test whether in case of evaluation we are using a distributed sampler or not. So this will basically testing ensures that if there is any code change, then we need to make sure that it is backward compatible at a certain level. It doesn't like break something else. So for each particular addition, for each bug fix, for each addition or feature, we of course like highly ensure that we highly recommend that you should write tests, right? So we can start the test part. First part is done. Now to test, we can write a test name, test eval distributed sampler warning. Like you can name it anything just for the uh, so we need to add some doc strings here. Test that warning is phrased when distributed sampler is used with evaluation. Now now we are going to do like just a normal unit testing. So for unit testing here we need again for this one, if you are not sure how to write a test, comment on the PRs. We will be happy to help you. Of course, we can initialize a model, we can initialize a trainer, and we can do trainer. Now to write unit test, you need to have certain level of knowledge about code base. But yeah, it's we can help you with that as well. I mean, it's of course if someone is coming from outside, it's not of course true that they'll have all the knowledge, but yeah, we can help you with that. Data connector, attach data. This is required to write a unit test. Sorry, model. Now we are done. We are done till the part where if we call trainer.fit or do anything, it will raise a warning. So we can like to for in case of validation. Validation. The warning should be raised in both the cases. If we are doing even doing validation or if we are doing testing, it should be raised. So we can to like write this unit test. We can assign this state to the uh, validating and let's if you remember that to reset the to generate the data loader, we have a method called reset eval data loader, right? So we can use that here. So we can just call reset trainer and pass in the model. Second thing is we need to do the same thing. So we can just copy paste here and make some changes. Reset. Now this test will run, will not complain, but we need to catch the warning. That's all this test is about. So it's just this is where we use PyTest. PyTest helps us to catch the warnings and everything, right? Raises. So this is sort of like an API. You can refer PyTorch, PyTest documentation on how to catch the warnings. So we need to ensure that a warning is raised. A user warning should be raised, and it should match a string, right? Now, what was a string? We need to put a part of the string here. So you can copy this from here and let's move it. We can write part of it. It is, let's just write, it is recommended to use in device. Okay, it shouldn't be training, sorry, strategy. Let me fix this. Okay, now it is recommended to use single device strategy and yeah, done. We can move it. Let's close this. We can copy this as it is. Let's do the import for trainer function. I mean, it's a VS Code thing. If it identifies where it's coming from, it automatically adds that particular import. So it's pretty useful. So here at this point, we have already added data changes to our code base. This is done. This is done. Second, next thing is we need to update the docs. But before updating, let's see if it even works, right? So to check this out, we'll run some simple PyTest. So we identify in the code base, we see that it's present under test trainer connectors and test data connectors. So we can just run this whole complete all the tests in this file and then see if all passes. If it doesn't, then we need to check where we are missing. So here we go to test and we can do trainer connectors test data connector and let's verbose it. Okay, it's raising a warning. That means something is not correct, right? So it says that this did not raise a user warning, right? So we need to go back in our code base and see what's going wrong here. So it raises uh, let's see our test reset eval data loader. We have a coding model, we have a trainer, and what else do we need? Okay, awesome. Let's see if it's even coming at this point, right? So we can add a breakpoint here and see are we making some mistake. So let's do this thing. Okay, it doesn't. That means we missed some things in the in our test maybe. So let's remove this breakpoint and see what did we miss. We defined the trainer, but we haven't defined any strategies yet. We need to define what sort of, I mean, the warning will be raised only in case of distributed training, right? So we need to tell the trainer, okay, we need to run this in the distributed training. So for that one, we have flags. Strategy equals to DDP, and we specify devices as two. And since I'm running these tests on CPU, we can define accelerator as CPU. We don't need to define anything else. We don't need to limit our training or anything because it's sort of like a warning. Even if you want, you can do. I mean, forget. Okay, let's ignore it for this. Now let's see if our test passes. Okay, it's not passing. Something is fishy again. Let's see. I mean, it happens all the time. You need to ensure that text pass, not just the code bases of it, right? Okay, it's reaching at this point. That means it's going to have a distributed sampler, right? Now, at least we are one step ahead now. So let's see what it is. We have his instance. Let's use the debugging only. Right. Let's check the sampler. Okay, sampler is distributed sampler. So one first condition is sorry, one sec. This condition should satisfy. Second condition is what's our trainer function. So we can check it. That's one. It's validate. So yeah, it should raise the warning. Why isn't it raising? We need to check. Let's put a breakpoint here itself, right? To see whether warning is being raised or not. Ignore this. Okay, it's going to raise a warning, but for some reason it's not catching. So let's figure out what's going wrong. Let's see our error again. Did not raise user warning. Okay. Oh yeah, I found it. It's not raises. My bad. It wants. Raises is used for exceptions. Now let's see. Okay, it's not. It's raising a warning, but it is not matching. That means the string might be not correct, right? So let's see. It is recommended to use single device strategy. It is recommended to use single device strategy with evaluation. Okay, here's the typo. Recommended. Okay. Oh, again, let's. Okay, it is recommended to use single device strategy. It is recommended to use single device strategy. Did anyone see what might be going wrong here? It's recommended to use single device strategy. It is single device strategy. When the list submitted was, wait, it should catch here something and it's recommended to use. Does anyone see something they can comment? The warning raised, but it's raising, right? Okay, found it. It's again another typo. Should be it, not it. Happens all the time. Let's try it. Hope it runs now. Awesome. Test is done. We know that test is being raised because that is PyTorch thing. Sorry, PyTest thing. It should pass if it raises a warning like that. So we are done with the second part as well. We are done with the code base updates. We are done with the test. Now third part is we need to update the docs. So to update the docs, again, you need some sort of familiarity. If you don't have, ping us. We'll happy to help you. So if you see in this one, this is sort of like an evaluation doc that tells everything you need to know about testing part of PyTorch Lightning. So if you see this thing, we have testing and we have validation. So in testing, we already raised this warning in the documentation, right? We just all we need to do is like for simplicity, just copy it inside validation and we'll be done with the documentation part. If it's not there, then of course you need to add things and write this kind of the all this stuff by your own. So okay, we are done with the code base, we are done with the test, we are done with the docs. Now last thing is left is to update the change log. So whenever you are making some bug fixes, whenever you are adding some features, so you need to add an entry to the change log that represents where things are being changed. And whenever we are doing the release, it's helpful to know what all changes have been made on that particular release. So let's change log. For change log, all you need to do is visit this particular file. It's on the main uh, like at the top level of the package changelog.md. So what we did here, we added something. So we can just add an entry here that we added a warning or something. So let's put up an entry here. Let's add changelog later because we need to find the pull request uh, number to add it to a changelog. So let's do it later. Okay, so let's start with the Git part of it. Now we are done with the changes. We need to comment those changes and make a pull request. So let's uh, okay. So you can either use Git diff or something to check what all changes you have made, and you can also use other things as well. So we can verify our changes here, and once we are done, we can do a Git commit. So git commit is something that identifies what all changes that you have made to your code base in a particular hash commit, something like that. So we can write a simple commit, just 2 3 words that represents what the changes we made. So here we'll write git commit added warning for uh, distributed sampler in case of evaluation. Comment is done. We can check the comment using git log and see, okay, we have a comment. It's the hash file. Sorry, it's the hash file. We have the branch and the message that we want to play. So in this, if you see in this comment, in this particular statement, we have hyphen am. So a is basically meant for if you want to uh, how to explain, you need to commit those changes or not. I mean, you need to add those changes or not. M is message. So you can do either, you can either add it first and then write a message, or you can use the shortcut to add it and also add a message. So we are done with the commit. Then now we can create a pull request. So to create a pull request, you can just do git push origin master. So it will send a pull request to the master. Like it will basically send this particular branch to the upstream branch, and there you can tell that okay, these are the changes, and you have opened the pull request, and you can request reviewers for to review it. So if we go with to this particular thing, and let's refresh it. Okay, one sec. One sec. What went wrong? Let's see. Did I miss something? Not sure. Let's see for branches here. Nope, not here. Okay, sorry. My bad. It's not origin master. You need to define the origin where you want to make the changes, and you need to send the actual branch name that you are on. So yeah, my bad. Sorry. So now it says that okay, new branch has been sent to the remote repository, and you can go there and make some changes. So if we come here and see, we see that okay, we have a pop-up which says Rohit GR7 user is trying to merge this particular branch in the master branch. So we go and compare our pull request, and here we have the title. We can change it or do anything whatever we want, and we have certain things that we need to check. Is there any issue linked to this thing? Yes, we have an issue, so we can just put in this number and like fill these respective fields, right? Next thing is, was this discussed or approved? No, it was sort of discussed, but if you see here, it was posted by one of like a manager, so it's sort of discussed already. So we can uh, say that okay, it's approved. This next thing is, did we read? Of course, I've already read it. Did you make sure you cleared this one thing? Yes, it just adds a warning. It doesn't do multiple things. Did you update our documentation? Yes, we did. Did we make any tests? Yes. Did we check the test? Yes. Did we make any breaking changes? No, there are no breaking changes. Did we update the change log? We haven't yet, but we'll make it. So let's take it for now. And is this pull request ready for review? No, it is not. It's not yet. Check all items. We have already checked it. I mean, just fill it out, create it, and fill it out. For starters, I would suggest create a draft pull request and see if test passes. And once you are done with all the changes, once you are sure that okay, it's ready for review, go and publish your changes. So we are done with it. If you have access to the repositories, you can also add labels and stuff. If you are not having, let's ignore this. So once we are done with this, we are this is not mandatory for all the repositories. Like this is some sort of template that is being requested by the owners of the repository, so that they can know okay what all changes have been made and what all things needs to be reviewed. So we can just uh, make sure that okay we submitted our pull request. It's still draft. No one is being notified, and we can see down there that tests have started running. So the one test that you added, if it works, it will pass and we will see all greens. So if you remember, we need to add a changelog as well, right? So we go back and go to the changelog MD and just add an entry here. It's no rocket science. So we have this particular thing and just call it copy paste it. Added what warning when using distributed sampler during eval. And this was a commit, so we can just change it 11479. Now we had the changelog and we are done with this. All the things that we need to do to make a pull request are completed. So we can go to the terminal back and see what all changes we made. We can do a git diff and see we just added a changelog. So again, we can do a commit added entry in change log. Done. All are saved. We can check the status and just do a push. If you already have pushed your changes to the remote branch once, then you don't need to like specify origin and the branch name. You can just do a git push and it will even. Okay, sorry. Okay, you are doing set. 1 second. Oh, I mean, it's been a while. I've used Git. I use only Git uh, CLI. So yeah, a lot of commands have changed. I guess Git push. It's the same. I guess we don't have much time, so let's see if we have any questions or not. It's something you can look and see why it's not working. It's not a big deal because we are done with all the changes. All we need to do is make a pull push, and that's all. So yeah, that's all you need to do. Make a pull request. It might be a lot when you are doing it first time, but it's not much when you get used to it. So it's useful. Like if you are using a software, you should start contributing to first. So if you are looking for any issues, let's say you are not a avid user of PyTorch Lighting and you need to find out issues that you can contribute to. So you can just go to the PyTorch Lighting repo and go to the issues and search for the label. So for new contributors, we have good first issue. You can come here, uh, check if any of these issues you can help with and make a pull request and you can ping anyone of the team from the team and they can help you with it. So yeah, that's all you need to know about PyTorch Lightning, like making your first contribution to PyTorch Lightning. So yeah, do you guys have any questions? Anyone have anything? You can ask on chat. Is there any documentation that sums up what you showed us today? There is a documentation. We of course will be recording this video. This is recorded. So if you want to know how you can make contributions, so you can go to PyTorch Lightning Docs. Down there you'll see a community section. So in community section there is a part where everything related to contributing, how you need to make a PR, what all changes are required, like everything is mentioned mostly. If there is something not there and you want it, of course, then it's a PR for you. Of course, it will be really helpful if you can help improve the stocks as well. Do we have more questions? Also, if you personally need any help, if you're contributing to Lightning, you can ping me, ping anyone from the team. You can join our Slack channel and you can discuss things or you can do crazy stuff here. Looks like we don't have any more questions, I guess. Yeah, uh, you can check the Slack link on the chat. Join, give us an intro about you on the introduction channel, and Taylor, please give me a heads up if we can end this stream or do we have more to do? Awesome. Yeah. See you guys on issues. Of course, like PRs are not the things that like it's not the only way you can contribute to lighting. You can open issues, go over to GitHub discussions and do stuff, whatever you want. Awesome. Thank you. Thank you everyone for joining. Yeah, I hope it was good. Like it was my first time, so yeah, it will be better next time if I made any mistake. Thanks.